Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about ISRO's RLV LEX mission. So let's dive right into it. Now, this is RLV, Reusable Launch Vehicle. Now, you have to understand there is some sort of miscommunication or misconfusion that people are saying this is for reducing launch costs. That's not its job. That's not its target. That's not its one going to do. Because it still needs a two-stage rocket or at best case scenario, because again, this is a mock-up kind of scenario where it's not full scale. So if they have to make it full scale and try to integrate second stage in it, can it be done? Yes, absolutely, it can be done. It's just that payload will be much smaller. So you may be like, what's the point? If payload is small, then how can you reduce cost? It's not designed for that. That's not its final mission. Yes, can you use this puppy to launch cube satellites? Yes, but it won't be cost effective. Meaning, if you actually went to someone and is like, hey, I want to use RLV for launching CubeSat, they will find the nearest homing missile system and they will fire it up your ass. It's a really dumb idea. Then why ISRO is spending so much money on it? Well, here's the deal. This sort of tool is what we call tool booster, meaning once you have this, you can unlock new things. You can make better tools using that tool. For example, USA has this puppy. Now, what is the unique aspect of this? This is something that you put on a big rocket, like two-stage rocket, and you launch it in space. Then what's the difference between this or any other satellite? This is designed to return. So what can you do with it? You have a tiny payload bay, okay? And that payload bay opens and closes, meaning you can put things that is on an actuator, for example, solar panels, and you can just go to space, open the doors, deploy it in space, and test all the things. For example, there is no substitute for real testing. Like, you think that your solar panel will work and provide this amount of energy. The moment you put it in space, good luck. You could have a scenario where everything matches up, or you could have a scenario where like everything does matches up, but it randomly dies after like, few months. How would you know? There is no alternate. This is the only way to testing it. This puppy can stay in orbit for upwards of 900 days. Basically, this puppy can stay there for, I'm pretty sure it can stay there for very, very long time. And it has a small thruster, so it can change its orbit inclination very slowly, but it can change it also. So that's the amazing aspect of it. If India truly builds something like this, and it has even a small payload, that's more than good enough for running every single tool through that experiments. Meaning, if like, hey, we want to use this synthetic aperture radar, make a small version of it, launch it on this, test it out. Does it actually work? Does it have like, same noise floor that they were expecting? Is there any fault in it? You want to test ion engine, put it here, launch it, test it, real world data, and the things will be returned back to you. Meaning that let's say a panel failed. Let's say you thought this panel should be amazing. Let's say you had tri-junction solar panels that is like 51% efficient. You're like, damn, this is awesome for military satellites. Again, super expensive, cannot be used for commercial satellites. You can be used, but like you have to be Jeff Bezos for that. So it can be used, but like, do you know those panels will last for, because again, we have enough data for silicon system, but you want that for some reason, let's say you want that tri-junction system. How do you know that this is going to work for years on end? The best thing is put in this, launch it up there, and just collect data over time. And not to mention, because you're going to return the samples will be returned, you can study it. You can properly study it in Earth scope rather than relying on statistical data. You can be like, hey, oh, I think there is a lot of micro cracks development, or a lot of this or that. Like, you can figure out all of those things. So that's why this sort of tool is very important. And that's why USA is like very hush about this, because we cannot even imagine what amount of things this puppy can do. This will like, we had this idea. Some engineer will like, okay, build it, put it on this extra 37, I think, and just yoit it into orbit and figure it out. Does it work? Does it not work? They can fine tune all their tools, and all their tools will go from, okay, hope it works, to, bro, we got this. That is like flat out priceless. And anything that you want to return back, for example, biological samples, let's say spacesuit samples where you need to return it in order to study it properly, this is like, shut up and take my money. So it's one of those things, and there is no alternate for real world space testing. So that's why ISRO is developing it, and that's why USA is so hush about this. And China apparently has a variant of this, but they have not. Nobody is exactly clear, but like there are some rumors that they have something like this, and I would be surprised if they do not. This is like shut up and take my money kind of technology. Imagine testing everything that you want to put in a satellite in actual real space environment. That's awesome. So what were the technology? Now, to make sure that this puppy comes in and lands reliably, they needed to develop something personal. So it has localized navigation system using pseudo satellites. What does that mean? That simply means any runway that would be selected for it, or all the runways, like let's say there are 3 runways for landing, all those runways will have pseudo satellites. They're basically transmitters that are from ground rather than from satellites, but from receiver's point of view it will look like a satellite, and that will give precision data where exactly is the radar. So basically think of them as like instrument landing system, only turbocharged to work on much larger scale. So that's has been used. There are many other systems that do utilize it, but India is developing their own lineup for it, completely homegrown system. So that will allow this tiny puppy to work amazing magic, reliably land. Then we have digital elevation model. Basically, this technology was developed for cruise missiles because cruise missiles have this issue where they can fly very close to basically surface, so avoid all radar detection. That's awesome. Problem, like sometimes if they are that close to her, their satellite reception is not that great, and not to mention GPS was not ready. Cruise missile is earlier than GPS, so there was an issue. How the heck you guide it? Somebody's like, hey, scan the goddamn area, create a map data, feed that map data, basically digital elevation model. That model scan that data, and then hope using that for guidance. And that's how surprisingly large amount of cruise missiles were guided. And of course that was like back in the analog computer era, so it was good but not that great. Now we have digital elevation model, and this puppies are precise. It's like, bro, I'm saying I'm gonna go there, I'm gonna go there. And this is have other users also. For example, if you're gonna land on Mars, how the heck do you think rovers know where they have to go? Digital elevation model, meaning they scan the area, they're like, okay, they have a rough idea, of course, created by some either computer simulations or other satellite data from other past missions, and that's how they figured it out. Once they have that elevation model, they're like, I'm gonna go here, and that's exactly where I'm gonna go. So India is developing a local variant of that. Then it has Ka radar altimeter. Now altimeters are very important because again we do have rudimentary altimeters even on basic things, but they're not very precise. And when you are talking about something that is fast, and I mean it has to be fast, it has to touch a runway at very high speed, it needs to be very precise. It has to be precise in such a way where it's like, no, feet are like too what you call sloppy of a measurement unit. Of course it can work, of course it will design in such a way that if there is a slop in error in calculations, it will still work, it will still default to the safe value, but it's like you need a good tool. That's why they are using Ka band, that is 27 gigahertz to 40 gigahertz. It's very precise. So if it's saying 18,225 feet, that's exactly what you are at. There is no the margin of error is very tight using Ka bands. And all of these technologies right now that they are developing will trickle down to DRDO and ISRO. DRDO is India's DARPA, and ISRO is ISRO. So it's one of those things that developing this directly has no benefit, but over time it's like, oh, ISRO can do this also. ISRO can do this also. DARPA will like, oh, our BrahMos missile that is Mach 3 capable can do this also. Digital elevation model. So I'm pretty sure that DARPA also has some DARPA, I'm saying DRDO has their own special sauce, some extra love into it. That's why, because it's a collaboration project. So they're developing there some awesome tool, and it's the easiest way to develop high level technology. All this technology will trickle down. And then we had Chinook, that again apparently that's its whole role. Chinook is used in India, it's used in America, Europe is doing it right now. They're also testing their re-entry vehicle. So that's how Chinooks are used. It's a common thing to do. Then we come to the test aspect of it. The test was done on 2 April 2023, 7:10 a.m. and Indian Standard Time. So it was a complete success, meaning what it's supposed to do, it did that. But this puppy was loud, and I have a link video down below. I would urge you to watch it because you will be shocked how loud this was. Now, here's the deal. It has no engine, so why the heck it's so loud? Because it does not have wing to body ratio that is very good. It's not a glider. If glider goes by, you will rarely hear it. If jumbo jet goes by, somewhat hear it. Aeroplane goes by, like fighter jet, you will hear it. This puppy is very loud and without engine. The reason for that is when it's doing this maneuver, it's at 350 kmph kind of speed. It's like it's fast, and that's why it also needs drogue chute. Now, can it land without the drogue chute? Yes, the runway has to be exponentially long, but that's one of the way of doing it. I would urge you, just watch it. And again, you can hear the people's cheer, and the area is surprisingly quiet, and you can hear bird chirping. That's how I know like this puppy is loud. When it actually starts to come in close by, it's like whoosh, and that's just aerodynamic noise. So that's the test aspect of it. It was complete success, and it did do what it exactly needed to do. Everything is fine, everything is dandy. Then we come to the expectation of final test. So we had first test, this puppy, the actual launching it, and this puppy was launched to around very high altitude, 68 kind of kilometers, and it did hypersonic re-entry, meaning at Mach 5 re-entry to do heat shield testing and all that jazz. Then the second test, again, that happened on 1:30 Universal Time Coordinate, 23 May 2016. And the second test, this puppy, this happened on 1:40 Universal Time Coordinate, 2 April 2023. Now, third test will be the final scale model. These are scale that will be full size model that will be put on top of a GSLV rocket and launched. That would be the final thing. Basically, once that third test is done, because again, we have already tested heat shield, we have also already tested basically all the navigation equipments. Once is made into full size and done a final test, then this will be basically a catalog material for ISRO. Right now, ISRO has like PSLV, GSLV, these are the catalog materials. We have this, you can order it, book it, whatever have you. This will reach that catalog the moment the third and final test will be done. And it will require a minor modification to GSLV, but let's see, that should not be that difficult. However, now we come to the bit spicy part of it. Now, ISRO in the early days, like as in like late 2010s, was surprisingly successful. The reason was that back in that time, there was only two options. You had Roscosmos or you had NASA, and both of them were idiotically expensive, meaning from their point of view, ISRO was free. That's how big the price cap was. And ISRO literally worked their ass off to truly, like, start to nibble away at it, then started to chip away at it, and then like, yeet, they started to take very large chunks of private launching market. And that also helped ISRO to gain bigger market share, because again, governments do not have that kind of luxury where they can just take money. Defense sector has that, but everything else is like, you have to show some value to it. So ISRO was like, hey, if you give us money, we develop a better rocket. That better rocket allows us to get more better contracts, and we bring money into it. Like, we bring dollar inside. So everybody was happy, and ISRO was doing amazingly well. If you look at the PSLV records, it's awesome. PSLV did so many things, it was like, damn. And GSLV Mark III was built. That was a heavy lift vehicle for geostationary situation, and that is also very successful. It's all, of course, it did not launch as many as PSLV, but again, if anybody needed to launch some big puppy to big orbits, basically geostationary kind of orbit, they had only three options. Like, they can go to ESA, good luck. They can go to NASA, really good luck. Or they can go to Russia. It could work out, but again, they generally always had their slots full. Or you can come to ISRO, and ISRO was very happy with it. So it was quite well. Now, right now, it's still the same thing. However, we have a new puppy in the town, which we call private enterprise. Back in the day, space versus basically corporation, national corporation versus national corporation, we had a very good advantage. But the moment you put private companies into it, things kind of change, because you have to understand that this re-entry launch vehicle, this puppy took 6 years, 10 months to go from test 1 to test 2. That's slow. Now, again, from a government point of view, that's super fast. But from a point of private company, 6 years. Do you remember what you used to know about Electron rocket back then, 6 years ago? That's the whole point. It's very scary. So all these private players, they are fast, meaning, of course, SpaceX started with 100 million, but all other companies, they are starting with, sometimes they are starting with even bigger budgets, and they are starting with even smaller budget. And all of them are fast. For example, SpaceX have reached a point where they can easily do 50 launches a year. Basically, 2 launches per month is guaranteed for them. 2 launches, I'm saying, basically weekly launches is done for them. It's like they can launch 1 rocket per week easily now. Like, they got it. If they are not doing it, of course, because there is no demand or some malfunction has happened, like, it can be done for them, like, which was unheard of. They reached there. Then we have to Rocket Lab. Again, Rocket Lab went from who gives a damn to like, holy damn, they are launching so many, they are making so much money that they are upgrading from Electron to Neutron rocket. That will directly compete with GSLV Mark III. And then we have Relativity Space, which already launched. Now, his deal, the launch was not successful. They did not reach orbit. But critical aspect is, this is so novel that there is no alternative for this. This is so cheap if the things are done correctly. It does not need to be reused. It's like, it's so cheap. Like, how exactly we made pens cheaper, because we started to make refills, and then refill was like, but again, somebody figured out, hey, we can make whole refill itself as a pen, which we call liquefico. Basically, like, you write it and you throw it once it's done. So same thing with basically this relativity. The rocket is built so cheaply and built in one go, quote unquote. It's like, hey, just build it, eat it. If it works, awesome. If it does not work, who cares about it? We can just build another one in 3 months. That's mind-blowing. And not to mention, this is a big capable rocket. It's not tiny rocket. It's a big capable rocket. And they are the only company that I know of so far that launched it, and they got everything working in first go. First stage is like, bro, I'm done. First stage is fully sorted. It's like there is not even a doubt about first stage anymore. Second stage was like the engine was not lit properly. But first stage is like, bro, I'm sorted. I'm done. So that fundamentally means before the third test of ISRO happens, there is a very good chance this puppy, unless something bad happens or something fundamentally broken comes up, they should be able to reach orbit and they should be able to put client payload in orbit. And that's scary because again, this will eliminate any advantage. So all those things lead us to one core point. ISRO really needs to upgrade their speed because the current speed, I'm pretty sure this puppy will be finished. And this is a manned air, basically manned spacecraft. This will be ready before that. So that is one of those things that I'm kind of sad about, is that ISRO is on the right track. This sort of tool development is awesome. It's necessary. It does turbocharge your development, but you gotta be fast about it. It's like, bro, we cannot go from like, I did one basic testing to another testing is 6 years from now. Like, dude, I'll lose whatever hair I have left. So it's one of those things that ISRO really needs to, apply right gear. Right now they are on the right track, but they do not have right speed setting. They need more speed. Otherwise, like, will be like very difficult position for us, because again, ISRO's budget can be cut. DRDO budget won't be cut, but ISRO's budget can be cut. So we have to be mindful about this. So this was my presentation on this small test. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.